Hello everyone, welcome to my channel. This is Leo, and let's do some more Leetcode problems today. So today's problem is minimize the maximum of two arrays. So we have two arrays, array 1 and array 2, which are empty. And we need to add positive integers into both of them such that they satisfy the following conditions. Array 1 contains unique count 1 distinct positive integers, and each of which is not divisible by divisor 1, while array 2 contains unique count 2 distinct positive integers, each of which is not divisible by divisor 2. Then no integer is present in both array 1 and array 2. And we were given the divisor 1, divisor 2, unique count 1, unique count 2, and we need to return the minimum possible maximum integer that can be present in either array. So that said, it's like a positive integer sequence, and we're going to allocate them into two arrays according to the rules here. And we're going to find the minimum possible maximum integer in either array. That means if we allowed, let's take a look at the example here. So if the divisor 1 is 2, divisor 2 is 7, and unique count 1 is 1, which means there can only be one element in the first array, and unique count 2 equals to 3, which is there are maximum 3 numbers in array 2. And we start from 1, so 1, is it divisible by divisor 1? No, so we can put it into array 1. And 2, is it divisible by divisor 2? No, so we put it into array 2. So we can put 2, 3, 4 into array 2. So that satisfies all the conditions here. And the maximum is the last element that we put into array 2, right? So this is how it works, actually. So how do we approach this problem? So this is something related to natural number sequences, and we are going to return the minimum possible maximum integer. And there are some conditions here, so we naturally think of binary search. If we can do a binary search on the minimum possible maximum number, we will get the number there. So let's say we have a left boundary of 1, of course, and the right boundary, which is like the maximum of all the numbers here, and we have a minimum number. And if the minimum number satisfies all the conditions, are we going more or less? Of course, we're going less because we're going to return the minimum possible maximum integer, right? So it's the minimum one. So we will put the right boundary to middle. Otherwise, if it doesn't satisfy all the conditions here, we will put the left boundary to mid plus 1 because the left boundary doesn't satisfy the conditions here. Okay, and let's try this first. Okay, so left equals to 1 and right equals to max value, and while left is less than right, middle is left plus right minus left divided by 2. And if it doesn't satisfy the condition, so we can say like not enough. If it doesn't satisfy the function, we can increment the left boundary. Else, if it satisfies all the conditions, we have to move our right boundary to the mid. And in the end, we're going to return left as it is the minimum possible boundary. And the accident condition is when left equals to right. Okay? So now how do we judge if it's enough or not. Let's take a closer look here. Array 1 contains unique count 1 distinct positive integers, and each of which is not divisible by divisor 1. So we can say we have like some numbers. Of course, the number is here, like the maximum number is here. And if it's within this unique count, and it is not divisible by divisor 1, and that satisfies the first condition. And we have another condition here for the judgment. And third, no integer is present in both array 1 and array 2. That is that is easy. So that means we cannot have duplicates, right? So let's try it. We have like mid and unique count 1 and divisor 1 and unique count 2 and divisor 2. Okay, I think that should work. Let's see. So Boolean not enough. We have a mid. We have a unique count 1. And we have divisor 1. Also, we have a unique count 2 and divisor 2. Okay. So how do we do this? We first have to know how many numbers are there. So if the number that satisfies the first condition is less than unique count 1, then we should have more of that about it, right? We should have more. So that's not the minimum possible maximum integer. So we want more, but not more than unique count 1. So let's say we have a number. Oh, maybe I should change it to n. All right. So the number that satisfies the condition is n minus n divided by divisor 1. Because the first condition says the satisfying numbers were not divisible by divisor 1. So if we spread that out, we get number A. And in the same manner, B equals to n divided by divisor 2. Okay? And no integer is present in both array 1 and array 2. So if we have A and B, we're doing some duplicates because they will both contain something that is both divisible by divisor 1 and divisor 2. Right? So we have to address this. Something that is not divisible by both divisor 1 and divisor 2. Okay? Therefore, we come to number C. So the number of divisor 1 divisible by divisor 1 is this, and the total number of divisible by divisor 2 is like this, and we have to subtract the number that is like lowest common multiple, least common multiple of divisor 1 and divisor 2. Okay? All right? And that's something that is divisible by divisor 1, divisible by divisor 2, and not divisible by both 1 and 2. So if we use n to subtract these part out, we will get an answer that is not divisible by both 1 and 2. Okay? So now we can continue with our judgment. So if A is less than unique count 1, then return true. That is not enough. And if B is less than unique count 2, that means the second array is still not enough. So we will return true in this case. And if C, no, it's A plus B minus C. That means not divisible by 1, not divisible by 2, and since we're adding something duplicate, we have 2 C's, we have to subtract this 1 C from there. If it's less than unique count 1 plus unique count 2, means we still have some spaces for both arrays. It will return true, okay? Otherwise, we return false. Okay? So now let's see, we only have a number. We only have one function left, which is the LCM. I believe it should be integer d1, integer d2. So for LCM, we can only return d1 times d2 and divided by their greatest common divisor, d1, d2. Okay. And for the greatest common divisor, so if like d2 is 0, we can return d1. Otherwise, we'll return the greatest common divisor, d2 with d1 modularized by d2. Okay. So in this sense, we should be finding the minimum maximum integer in here that satisfies all the conditions. Okay, let's try it. Okay, I think it passes all the test cases. Let's submit it. Oh, there's some wrong answer. Oh, I think it's, yeah. I think it's about, yeah, the boundary thing. So we can actually cast them all to long and cast it back to int. Well, in that case, long here, long. Yeah, sometimes you have to take care of this. Let's see. Oh, 10 to the power of 9. So yeah, that should be it. And this is long as well. Okay. All right, and also this is long. So the logic is right, but it's just the implementation. You have to take care of the boundaries of either integer or long. Okay, let's see. Yeah, I think it passed. And thank you so much for watching. I'll see you in our next video.